Section 2, Compute Services. In this section of the course, we're going to mainly focus on compute and then discuss the different options available. We'll get into what EC2 instances are. We'll go through a lot of demos on the different compute services. We'll go through some whiteboards as well. We'll talk about cost optimization, auto scaling, the marketplace, and the cost calculator. We have a lot to learn. Let us go ahead and continue and move on to the next module. AWS Compute Services. Let's discuss compute options in AWS. Now, first to be aware of is that when we talk about compute, it's not really the sense that we're deploying a physical server or anything. We're effectively using components from an abstraction approach such as CPUs and RAM as well. Now, basically, if we had a physical server on-prem, that's of course our server. But basically, when it comes to deploying compute services in the cloud, we're effectively using resources that are virtualized. This is, of course, really important to be aware of as well. Now, AWS has numerous options for deploying compute. Some of these options could be everything from Amazon EC2 to Elastic Container Registry, Kubernetes Service, Lightsail, etc. AWS does, of course, provide different options and different types of services, as we could see, but it is important to realize that these services, most of these we could dynamically provision and pay for only what we need. This is really a big deal because we don't need to actually have significant CapEx funds or even CapEx funds at all. We could just basically use our OpEx funds and deploy these resources. Now, EC2 is, of course, the most commonly used service in AWS. It allows us to integrate with other features such as choosing the AMI that we want to use. We could use Elastic Block Store. We could use an external IP, which is called an Elastic IP, etc. So there's a lot of great capabilities. Now, when it comes to AWS, its infrastructure is, of course, comprised of physical servers. They manage these. When you deploy a VM instance, it's effectively, again, an instance that uses what's called a guest operating system. AWS is going to manage all this. You don't really need to worry about it. You just select your image, and then you can then install your OS or other applications on top, whatever you want to do. I'll walk you through demos of this in the course here, but again, fairly straightforward from a compute perspective. Other services such as Elastic Beanstalk, widely used platform as a service in AWS, very solid capability as well. Now, also too, we have some other services such as Lambda and Fargate, etc. Now, Lambda, for example, is a serverless compute service. It's going to allow us to execute code when we want to. It's a stateless-based service. It does support specific languages, though, so it's really, again, needs to be within those guidelines that AWS supports. Node.js, Java, Go, Python, Ruby, and I think C# are the current supported runtime environments. Now, I'll talk more about Lambda. I'll walk you through a demo. Basically, a Lambda app is really a function. There's runtimes. There's different terms that go with it. Mainly, I talk significantly more about Lambda in the systems operation course and the architect course. That's where you really need to know the details. Now, there's also other capabilities like VMware Cloud on AWS. Amazing capability where customers can extend their VMware environment from on-prem out to AWS. Now, when it comes to compute capabilities, there's, of course, a lot more capabilities. The demos will address the major capabilities. Again, this course is really meant as an overview. One thing to talk about, for example, is the container services. I did want to touch on one thing before we proceeded on to the next module. Basically, for example, if we need to deploy container-based apps, we could use Elastic Container Registry. We could use Container Service as well. Basically supports Kubernetes, Docker containers in that manner. Now, there's, of course, other capabilities such as load balancing, auto scaling. I'll talk more about those in those sections that I have set up. Let's move on to the next module. AWS EC2 instances. Let's talk about the options and types that are available. When we deploy VMs, it's not as simple as picking from a choice of 2 or 3. There's a lot of different options, capabilities that we can deploy. We can deploy basically Linux or Windows-based services as we choose. A lot of great capabilities. Now, when it comes to EC2 instances, it's really, again, understanding what's available, what you need, and how you can deploy it. But there's also a lot of costing that goes into that as well to understand how all this works. Now, it's also important to realize that EC2 is a regional service. So if you deploy it in Northern Virginia, it's deployed in Northern Virginia. If you deploy it in Brazil, it's deployed down there. So just be aware of that as well. Now, EC2, one thing to point out is basically built on top of the Nitro system. Now, this is a next generation of EC2 instances. Basically, in the previous versions, they used hypervisors that would protect all the hardware, the networking, the capabilities. The Nitro system basically is meant to offload to dedicated hardware and then try to reduce some of the costs as part of that. So the Nitro hypervisor is really meant and built for performance and is similar to more like a bare metal approach and generally has performed better than typically the Xen hypervisor, which was the predecessor before. Now, when it comes to images, we have in the world of Amazon, basically package OSs and any installations that are in a template are called Amazon machine images. Now, when we deploy these instances, we need to pick an image. So for example, the instance type is going to, of course, define the CPU, the memory, the storage, etc., and any kind of applications we want to install on it. We also can choose the size, like how much memory and the CPUs that are supported as well. There's a lot of things to consider. Now, when we deploy an EC2 instance, the way they're provisioned and paid for is important to realize. We have on-demand instances. This is basically where we log into AWS and we effectively just select configure EC2 and then we deploy that instance. That's on demand. Now, reserved instances are basically going to be commitments that we make with AWS for specific compute-related capacity, that is. And then spot instances are basically sort of similar to the clearance aisle at a store, but in the world of virtual machines, basically these are resources available that AWS has given you at a significant discount, but the way these work a little bit different than typically an on-demand or reserved instance. Now, spot instances are meant to run for 24 hours. They're not meant to run for all week or all month. Basically, you could save up to 90% if you use those. They're really good for batch jobs or basically short-term ingestion-based tools that we might be using, like with the Hadoop, to bring data into a data warehouse, like for migration, whatever that may be. but it is an auction approach in the sense that AWS sort of tells you what they'll accept to run the instance, and then you go ahead and try to get it lower, but you may not actually get that instance, or you have to wait a while for that price to go down. So that's really an interesting perspective as compared to other cloud providers that I'm aware of. Now let's talk about instance types. Now, AWS uses what's called an instance type. It's basically defined over here by the type and the acronyms that they use are abbreviations like T2, M5, C5, R4, XLE, etc. Basically, to really understand what all this means, there's quite a bit of work you have to do to understand the difference between each of these types of instances. Now, simply put though, it's really by the use case. For example, if I'm deploying a WordPress site, general purpose is perfectly fine. On the other hand, if I want to deploy a GPU or some kind of advanced processing capability, let's say for machine learning or AI, or even perhaps gaming, accelerated computing would be a better choice. On the other hand, if I want to run a heavy type of query, data service, maybe compute optimized is better. Again, it's all about the use case. If I need to have, for example, really fast SSDs, maybe storage optimized is better. Basically, the instance types are there to help you select your instance based on a use case. So let's go to a demo now and talk about EC2 spot instances. In this demo, let's go ahead and walk through how we would deploy an EC2 instance. Before we get started, what we want to do first is, of course, go to the EC2 dashboard. To do that, we go to recently visited services if you've accessed it before, or simply just go down the first time over to launch a VM, or you could always go and type EC2 here. When I select that, it'll bring me over to the dashboard. Now, when we look at this, remember I need to pay attention to what? The region that I am in. When I select running instances, you can see that I have 2 instances running and 1 has been terminated. What I'd like to do now is go ahead and deploy another instance. To do that is relatively simple. Let's go ahead and go to Launch Instances. The first thing I want to point out is when you look at an image on the left here, you'll see that it says free tier eligible. And I can always go over here to the left and select free tier only. That'll bring up the operating system images that are available for the free tier. Now, let's go back up and I'm going to select the first image, which is the Amazon Linux. You can see when I go and select the operating system AMI, it then has more detailed images that we could select. And you'll notice that only one here is actually a free tier eligible configuration. What I want to do is just go ahead and select that. I could go over here to configure instance details. Now, before we get started, a couple things on this interface to cover. The first thing is, as you see, it says the number of instances. So I could deploy 1 or more of these. Basically, if I want to deploy 1, I just leave it there. If I want to deploy 10, I can, of course, select whatever I want, 8, 10, whatever. So you get 1,000. And again, now remember, this is a free tier. You can't just deploy 1,000 VMs and expect it to be free for too long. You only get 750 micro instance hours. So it's not a lot of time, but it's enough to run a few of these and do a little bit of work on them. Now, I'm just going to go ahead and leave it at 1. That's all we need. Now, if we had created an auto-scaling group, I would select that. We'll go through auto scan a little bit later in the course. Now I could go over here to select a spot instance. I have a separate demo on that, so I'll hold off on that because that's a little bit more detailed than what we want to look for. This is where we select the networking, the subnetting. I'm going to leave that as a default. A lot of these areas here I'll cover later on, for example, like monitoring, CloudWatch. I have a section on CloudWatch. We'll be talking about monitoring. If we want to enable CloudWatch detailed monitoring, the easiest thing to do is to just enable it at the deployment of the EC2 instance instead of having to log in and add the agents later. So just be aware that's the easiest thing you could do. Down here, we have other areas we can configure. I'm going to hold off. This is more just a demo to show you how to deploy an instance. And I'll be talking more about EC2 storage when we get to that module coming up. I'm going to walk you through the different volume types available and explain maybe why you want to use one over the other. Now, tags. Tags are important in a lot of cases for organizations that really have a large deployment, but also, for example, have a lot of different departments per se, locations, applications, whatever that is. Using tags can really help you identify the resource and how to apply, for example, chargeback to it. This is just one of the reasons to use tagging. Could be for monitoring, could be for security, tags, whatever that requirement is, you can use tagging very flexibly. Now, security groups. Security group is basically a firewall rule we're going to add. Think of it as a group of firewall rules, I really should say. And you can see here that by default, SSH is available. Let's say, for example, if I wanted to add another rule, custom HTTP traffic, for example, or DNS, I could go over here and add, for example, let's see here, HTTPS. And you can see before I select that, you can see here that it also has default firewall rules, for example, already programmed for some of the application traffic you might have, like MySQL or POP3, SMB. So I'm going to go ahead and select that LDAP as well. You can see that it'll populate that for you. Then what I could go ahead and do is select, do I want SSH to be available on a custom CEDA range or do I not? Could add description, for example. And I'll go more into this in the security section. And then over here, what I might want to say is just from like my IP address, I'll be able to SSH to this EC2 instance. And then custom, I can go ahead and say anywhere because this might be web traffic. It's an application that we're going to be running on it, whatever that use case is. I could say this is the customer app. Then I go to the review section, basically the summary. And over here, what we want to do is just be aware of the key pairs. Now, I could go ahead and create a new key pair, what I would want to do. Now, why do we need a key pair? Remember that we need to have a key pair for SSH. So if we want to log in and manage our instances, we need to have a private key and a public key. Now, AWS is going to provide one end, but you need to have the private key that we're going to keep locally on our desktop. I'm going to go ahead and call this AWS course SSH key. And I think I spelled course wrong. Okay. So you can see there the AWS course SSH key. I'm going to download this key. So what I need to do is save this key. And to do that, just save it in your folders. So I'm going to go ahead and copy that. And I'm going to paste it to my desktop to have it easy reference. Now, you don't really want to normally keep on your desktop PEM files because that's like wide out in the open, especially at work if you walk away or whatever. So just be aware for demo purposes, that's all I'm doing. Now, because I have the key set up, I'm ready to go. I'm going to go ahead and launch the instance. Now, you can see here a launch log. Let's go ahead and view the progress. You can see that really launches very quickly. So it's pretty much initiated. Let's go over here, select the VM. When I select that link, you can see there that it's still pending the state. In about maybe 10 seconds or so, 20 at the most, it'll probably be green in reality. So again, the log shows it's pretty much changing state, so it should be available soon. Status checks will also come up, and also too, if you select CloudWatch monitoring, that installs another agent. So that takes a little bit longer than without that. So just be aware that might be what you see. Now we'll go ahead and change that here in a second, but let's go over here to the dashboard. You can see that there's 2 running instances, and then let's go back here. You can see that 2 are running, 1 is still pending, 1 has been terminated. And that'll be up shortly, so I'll come back to that when it is fully available. All right, so the instance is now available. It is running. And you can see here I have names. What we want to do now is I want to just go ahead and add a name. Now, this is more of a visual reference than anything, so you can identify what the VM is for. Basically, I'm going to call this demo VM1, let's say. Save that. All right, now you can see that status checks are still initializing. Now, you will notice if you deploy with CloudWatch detailed monitoring, it will take a little bit longer to boot up. And the status checks will take probably 5 to 10 minutes to come up fully, so just be aware of that. All right, that's really all you need to do to deploy a virtual machine. It's really quick to deploy an EC2 instance. Now let's scroll down here. You can see here that we have a submenu. When we scroll down, it gives you that information about the virtual machine. If I go to status checks, you can see here I could create an alarm. These are still coming up, and that's to be expected. That'll come up a little bit. Let's go to monitoring. What we could do here, this will show us any monitoring. This again will not be immediate. So what we would do is, just so you can see how it will look, is let's go over here to this application here that's been running. And if I scroll down, you can see that there's CPU utilization here. Disk reads are pretty low. Again, this is a Hello World app basically that's deployed. Not a lot of activity on it. And that's really what that monitoring would look like. Then when we get to the CloudWatch alarm section, I'll walk you through alarms and how to configure that. And then if we had any tags configured, again, it would show you the key value here as well. Now on this one here, this was configured for the App Engine instance. If we go back to the new VM we deployed, there again, only the name is there for the value. And then we could simply add more tags if we want. In this case here, maybe this is going to be WordPress. So I might want to call this WordPress, and then maybe call this site number 1 or e-commerce or whatever you may want to call it. And you see that that'll add that tag for the instance. So that's pretty much what it'll do. Okay. Now, as far as changing this again, you can see there I could go ahead and change the name again if I want, whatever I want to do. All right, so that really is the high-level demo of how to deploy an EC2 instance. We'll be walking you through later in some of the demos, spot instances, reserved instances as well. Let's go ahead and move on. Let's go ahead and talk about Amazon's Elastic Block Store. Now, Elastic Block Store is basically Amazon's version of a performance block storage device that we're going to use with EC2. It'll provide us basically throughput and also scale for those high-end workloads. For example, it could be an enterprise app, a relational database, whatever it is. Now, there's typically some choices we need to make. And to get to that, we could go actually to EC2. And remember, that's used with EC2. So what we want to do is scroll down to where it says Elastic Block Store. and we could select volumes. When we decide to create a volume, and before I create a volume, let's just talk about a few things. So here you could see that there's 4 volumes. By default, they're 8 gigabytes. It tells you the volume type, the number of IOPS that are supported, the snapshot, created when, the availability zone that it's in, and the state as well. And then if we scroll over, there's additional information around the status, monitoring, if it's attached, what instance it's attached to. What I could do next is select the volume type, and we have a couple choices here. We could select a GP, which is again a SSD device that's basically going to be typically limited to about 3,000 IOPS, depending on the configuration. Now, one thing I want to point out, if I go 1,000, that again is going to scale up to 3,000. If I select 100, you can see there that that has a range. That's the baseline of 3 IOPS per gig. And the minimum is 100 IOPS, but it's burstable to 3,000. So just be aware. That's going to, of course, be based on the requirements of the application. We're going to go ahead and set the availability zone. We could select a snapshot. We could also encrypt it as well and add tags. In this case here, what I want to do is, let's say I want to select a provisioned. Now, when I select a provisioned, you can see that I could scale up to 64,000 IOPS. And again, I could go ahead and play around with this. And then the IOPS would be minimum and maximum. So you can see the size. And then if I want more, you can see I go ahead and configure that as well. Now, again, that's really up to you to decide based on the requirements. Now, if you have a mission critical system, if you need a volume that's replicated, you could also select availability zones, for example, as well. So you have, again, a lot of choices to consider. There's also a cold hard disk drive. This is going to be very slow performance. And also, too, there's no guarantee for IOPS with this per se. Then there's throughput optimized. This has a range of 500 to about 16,000. And again, IOPS are not guaranteed with this, but you'll get a certain amount for throughput. Basically, that's the configuration. And then magnetic is standard. So if I go with GP and I just select the minimum size of 100, I can also, again, I'm just going to leave that there, create a volume. You can see there that that volume I just created, it'll eventually be created and show up there. And you can see that's in Ohio. Then if I go to US East and Northern Virginia, just to show you, you can see that when I select Northern Virginia, there are no EBS volumes that have been configured. And that's because, first of all, I didn't deploy any EC2 instances. And because this is an EC2 based resource, it's basically a regional resource, and it's really tied to, again, that specific region and zone. So you can see here, US East 2C, that's the availability zone. And now you can see that that was just created. This is 100 gigabytes, and that says available. Now, the blue is available. That means what I could do is I go over to the EC2 dashboard, and I could go launch a new instance, for example. Select the instance. And then again, I could go over here, scroll down. Let's go to storage here. And you can see the root is 8 gig. I could go over here, and also too, I could also configure the volume type and also change the size, of course, when I provision the EC2 instance. I do have a little bit more flexibility, though, if I configure it ahead of time. You go here to add a new volume. And again, I can go ahead and select EBS. It'll populate that as well. and I can go ahead and select that volume if I want as well. And again, I go ahead and add tags. I could also delete on termination. I want to select that because of the fact that if I don't, then when I delete the EC2 instance, it won't actually delete the volume. So just be aware of that. And then the next thing is to just review and launch. And then select a key pair. And I think I'm going to use that one. And that's really how simple it is to deploy EBS. And then let's go back to EC2. Select that, and you can see that that instance is pending. And again, as we did in the EC2 demo, it was, didn't take too long to deploy, especially if you didn't select monitoring, for example. So that really is Elastic Block Store. That's the main use case for it. There's a lot more that we could do, such as snapshots as well. And then there's also what's called a lifecycle manager. And this is where we create a policy. For this course, it's a little bit above an introductory level, so we'll skip over that. But I did want to show you snapshots. So what I could do is create a snapshot. And when I select create a snapshot, I'm going to go ahead and select the volume. So I'd want to know, for example, what the volume name is. And this is another thing too. If I filter by attributes, for example, if I had selected disk 1 or something, if I added metadata, this would make it a lot easier. Now, in a larger environment, you absolutely want to use tags and metadata. This will really help you out having that key value to identify the resource. So again, that's really how simple it is. Well, that's about all that I had for this demo. Let's move on. AWS EC2 spot instances. Now, we know that a spot instance is basically an auction approach to using basically AWS EC2 instances that are basically available. Basically, AWS has capacity that isn't being used. So what they do is they discount it greatly to help you run specific jobs like a batch file for a couple hours, instead of having to go out and get a reserved instance or an on-demand instance, which would be a higher cost. Now, the pricing for EC2 spot instances is going to be on the EC2 spot page. And what we want to do is scroll down, and you can see here that this is the current pricing for a spot instance, depending on the OS. So Linux and Windows are actually a little bit different in pricing, and you can see this here from the list. So just be aware that this will, of course, vary. And the resources available in different regions can vary greatly, so just be aware of that as well. Now, as you see here, there isn't a lot available in US West when it comes to the A1 or T2s, for example. And then if we scroll back up over here to Ohio, you can see that it seems like there's a lot of Linux GPs available. So that is how you would find spot instances for AWS for the pricing, that is. And then if we go over here to what's called a defined duration, spot instances are generally going to be 1 hour or 6 hours. Generally 1 hour is really not a lot of time, but you may be able to get done perhaps an ingestion process or a batch file, upload some data, whatever you're trying to use it for. And it's also priced differently for Windows. Now, if you go back up to the top, you could see, for example, here, this is where you could try EC2 for free. The free tier information is here. But before I actually go to the console and walk you through it in the console, what I want to do is talk about what's called the Spot Instance Advisor. So if I click that, this is basically going to be a tool you might want to use when you scroll down here, and it'll help you filter specific requirements, basically. So if you know you need Linux or Unix, select that. And then what is the amount of memory that you need? You put in whatever that amount of memory is in gigabytes, and you can see it'll filter that out for you. Also, too, you could select instance types by EMR, and you can see that'll filter that. And then also, too, vCPUs. If you need a minimum of 4, it'll filter that out for you. So this is the Spot Instance Advisor. And there's also, for example, Spot Fleet. This is really meant for basically larger collections of on-demand. So if you know you need like 1,000 instances, you might want to consider looking at this. So that is Spot Fleet. Let's go to the console now. So I'm in EC2, and basically let's just go back to the dashboard. You can see there I have 3 instances. And one of these I deployed earlier in the EC2 demo. So if I go down here to Spot Requests, go ahead and select that. I go over here and I don't have any running. So what I want to do is request a Spot instance. And I'm going to fill out this template basically. Do I need it for what type of task? What type of workload? I just need a defined duration, let's say, just 1 hour. And then I'm going to select the AMI. I could then select the instance type. By default, in this case, it's C4. Could basically select the VPC I want to use, availability zone, how much capacity, do I need 1, do I need more? I could then also add my keys as well as part of this, and then I could go ahead and launch it. And basically it created that. Basically, I just took the minimum bid, and it'll go ahead and fulfill that if that resource is still available for that pricing that was selected. So that is how you would deploy a Spot instance. And a couple other things too. You can see the state is open. That just means it hasn't been fulfilled yet. When resources open up and it meets that minimum bid, it'll deploy that VM and it'll notify me of that. Now, I do want to point out, for example, here it has a pricing history. This will tell you the pricing history compared to, in this case, on demand for this specific instance type. And again, I can go ahead and select the number of hours, days, whatever I'm looking for. And again, this is really good from a history perspective to give you an idea of costing. So I go ahead and close that out. And then I go over here to Saving Summary, and this will tell you the average cost per vCPU hour or memory hour that you're saving using a Spot instance. That is really how easy it is to deploy a Spot instance. And when that is taken, it could be in 5 minutes or it could be in 5 hours, whatever that is. It will go ahead and turn green and then basically deploy. With that said, that is a Spot instance and how to deploy it. Let's move on. Let's go ahead and talk about Elastic Beanstalk. Now, Elastic Beanstalk is one of my favorite services as well on AWS. If you like a solid platform as a service, EBS is a great choice when it comes to cloud environments. Now, the first thing we want to think about is, what is Elastic Beanstalk? This is going to be a platform as a service that we're going to deploy on. It is managed by AWS, and essentially what we would do is deploy a runtime environment on this platform. So we could deploy, for example, a sample application, or we could deploy our own application, whatever we feel like. Now, you can see here Northern Virginia, I'm selected. If I go to Ohio as well, you can see here, welcome to basically get started. So what you'd want to do is go click get started. Over here, what we want to do is put in application name. And remember too, we have some choices in what we deploy. For example, we could deploy Golang, Java, JavaScript, PHP as well, and several others like Python, you name it. With that said, I'm going to go ahead and put in a demo test app 1. And then I'm going to choose the platform. I'm going to go ahead and I want to use, let's say here, a Python-based application. I'm going to go ahead and use the sample app to get started. But if I had code I want to use, I could simply upload that as well. And I could go to GitHub, and AWS does have sample apps you can deploy as well there. But I'm going to go sample app. Going to go ahead and deploy it. And you can see here it's creating the demo test app. This will take a few minutes. We'll come back and check when it's done. Now we could see that the environment is starting right down here, and it should be fully available in about another minute or so. We'll come back and check. We could also go over here to the environments and see the status. You can see it still says pending. When that turns to basically available online, we'll come back and complete the lesson. Okay, so the demo test app has completed, and you can see here that it says a web server. It is Python running on Linux, and it is a sample application. The URL is listed here, so let's click on it. And you can see that, let's see here, health is okay. It is running the sample application, tells you what it is. This gives you that information here. And again, that is information on the deployment of that EBS instance. Now, if I select this link up here, this will bring me to the demo app, and basically it's just a static web page that is brought up. And that really is how simple it is to deploy an application with EBS. Now, if your developers are using this, then what they would want to do is just simply go and upload a new version of Python or version of whatever application they are using. Also, too, under the application, we have additional configuration information we could modify. We could also address rolling updates. We could address monitoring as well. Could address network configurations as well, and a lot more. Logging is done. This does take, for example, probably about 24 hours to start syncing up. Health, it'll give you the health of the application. And again, it'll check that on a routine basis, but just be aware it does take a little time to sync up. Monitoring. This will give you an immediate update on some of the stats, only 3% of the utilization of the CPU. As far as network in and network out, you could see not much activity. It is nothing but a demo app. We could set up alarms as well. You could also determine how updates are addressed. And again, we go up here to select that. Events. This will give us information on that. And then, of course, tagging. We want to tag our application, basically, for several reasons. We may want to tag it for monitoring, for billing, to identify with other services, for the firewalls, etc. Then over here, go to Actions. I could go over here to start the app server. I could rebuild the environment. I could also terminate it as well. I could also load a new config. So you can see there that there's quite a bit of capabilities. So these are the two applications running. So what I'm going to do now is delete the application. And what I need to do here is just copy this. And then I need to delete it. And I need to actually enter the name test app. That is, I should know that by now. And then delete. And that'll go ahead and delete. That will take a little bit of time to fully disappear. Once it's done, you're good to go. Now, also, I want to point out here, there is a CLI available with this as well for your developers, for them to log in locally. And then to get started, they give you instructions on after you log in how to set up your environment. Well, let's go ahead and move on. In this demo, what we want to do is deploy a function in Lambda. Now, Lambda is a function as a service, and we want to use Lambda when we want to run our code without having to provision or manage any servers. This, of course, can make our lives much easier, especially if it's just a small amount of code, and we just want to get it up and running and have a managed service. Now, Lambda has some benefits. First off, you don't have to manage servers. Second of all, it scales pretty much automatically. And it's only, from a payment perspective, only what you consume. It's not like you have to reserve it and pay for it forever. And also, too, performance is consistent. What we want to do here is go to Lambda. And you can see that I don't have any functions deployed. Now, before we get started, let's go to the dashboard, actually. And you can see here I'm under Ohio, US East. There is really nothing going on. And again, no functions available. So what I have to do is create one. I have a couple choices to make. First, we could create a new one from scratch. We could use a blueprint, which is more or less a step-by-step process we could follow, or we could just deploy a test app. In this case, I'm going to deploy the very simple Hello World. And the source code is directly available from GitHub, as you see. And it was developed by AWS. The template is listed here. As you can see, it's in Node.js here. And permissions tells you what the policy is set to be. A README file is listed here. And I need to do a few things. So this is a Hello World. And then I'm going to call this a test app, basically. And I'm just going to deploy it. And what this will do is deploy that function, and that function will be a very simple Hello World application. And it's being deployed. Over here, you'll see that the resources will load, creating in progress. And that will take probably just about under a minute usually. We'll come back and check. Okay, that function created. And now you can see that we have the Hello World resource deployed, and the role has been created. Now, I did want you to realize, too, that CloudFormation has been used, and that is an infrastructure as a service. In AWS, it uses templates, basically. Select Hello World here. And when I go there, you could see that this is the Hello World app here. I could add a trigger as well. This is the ARN. I can copy that here into that. And then here would be the code that was actually deployed. And you can see the license, the index.js. Here's the YAML file as well, and etc. So again, not much here. It's just a real simple test app. Now, when I go to the Hello World, there isn't really any layers yet. I need to add a trigger. Again, there's some more work to do with this. And then also too, I want to point this out. Click here to manage. Now you can see here, when I set up the development environment, I also have additional IDEs I could use. Visual Studio, Cloud9, SAM CLI, Visual Studio Code as well. And then down here is the logical ID of the resources again. And this is actually the designer. For the purposes of this exercise, I won't get into coding or anything like that. But again, this is here for you. Then you could always test it out after you make a change and create a test event. And then you just call this whatever you want. I think it's like test1 is okay. And then that'll go ahead and test it out. And if there's any issues, it'll come back with an error. Let's go back to the dashboard. And you can see there that the application is listed here. And when I go back, it says it's deployed. It gives me that information. With that said, that is the dashboard. There isn't going to be a lot of activity, of course. And that is, I think, about all that I want to cover for this demo. Now let's talk about compute briefly and just go through a quick refresher of compute services. Now, AWS, as we know, has EC2, Lambda, Lightsail, and of course there's Elastic Beanstalk, etc. So there's a good amount of compute choices. One of the things we want to pay attention to is be aware that we could use, for example, CloudFormation, which is an infrastructure as a service, to basically use templates, basically, via YAML. And it's hard to write, but let me go ahead and put that here. And what we could do is basically create a template, configuration script, and then deploy, for example, any number of EC2 instances. Also, in the marketplace, we have, of course, solutions that are pre-built, ready to go. Could be subscription-based or may not be subscription-based, could be free. And we could deploy, for example, a LAMP stack. We could deploy a blockchain. We could deploy a DevOps service like Jenkins or whatever you want to use. And also do that on EC2 as well. We could also deploy on Lambda or Lightsail if it's supported. Also, too, be aware, too, that we could use both of these services to deploy it on, for example, EKS, Container Service, or ECS. Once again, we have a lot of choices with compute, but also we have a lot of choices with how we can deploy on compute as well. And also, too, when we're deploying, for example, from on-prem, we do want to have some kind of SSH set up, for example, some kind of a gateway service. Perhaps a NAT service for outbound traffic, a Bastion host for inbound traffic. And with that said, there's a lot of options to consider as well. Also, too, we probably want to have load balancing, especially if we're going to use EC2. We have production applications on it. With that said, let's move on to the next module. In this demo, let's go ahead and talk about Lightsail and launch an instance of Amazon Lightsail. Now, Amazon Lightsail is a virtual private server that we're going to deploy on the AWS infrastructure. It does have a lot of similarities to EC2, but it's much less configurable, and you'll see how the process works here in a second. It is really meant for you to deploy snippets of code, basically, and do it really quickly. Now, what we want to do is go over here to build a virtual server. And we could also, of course, type in Lightsail as well. Either way will get you the same place. So you could see over here that I could select the instance if I want to select any kind of database, networking, storage, etc. And when I go create an instance, this will bring me over to the first step of the wizard. One of the things to pay attention to is we need to, of course, pay attention to the region that we want to deploy in. Not every region is supported. I'm going to use the default Virginia region in this case. I'm going to deploy Linux. And when I select the Linux, you can see there's 22 blueprints available for it. And then there's only 3 available for Windows. When I select Linux, I then can deploy WordPress, for example, a LAMP stack, Node.js, GitLab, etc. I'm going to go ahead and deploy a WordPress site. And I could also add a launch script and also use a SSH keep here as well. Now, the way this is priced out is similar to EC2, where there's memory optimized, processing-based storage, and also transfer-based. That's a little bit different than EC2. Now you can see there 7 terabytes. This is $160 a month for that. If you want to deploy a small 3 terabyte data transfer size, that would be $10 a month. If I go back here, I select the $350 a month. That would be, again, the first month free, just as a promotion. And then I would name the instance and how many instances I want to deploy. I then could add key values. So let's just say WordPress. And then I would say e-commerce, let's say. And then create an instance. And again, as you can see, relatively straightforward. And it basically says pending. And then over on the right, it pops up recommendations of how to manage your sites. And it also gives you promotions for GoDaddy, which I find interesting as well. Now, that is pending, and we'll come back when it is ready to go. Okay, now we could see that the WordPress instance is running. And after about 2 minutes, the instance should be available for you to log in. And this would be the link you want to select. This will connect via SSH to the instance. And now we're able to connect. And again, this is on a Linux platform. Just type your basic Linux commands to proceed. And that is how simple it is to get started. A couple of things over here, we go here and select basically connect. We could also select manage, stop, reboot. If I select manage, for example, this allows me to, for example, adjust additional disks or create an additional disk. Also look at metrics. This just booted up, so there isn't going to be a whole lot going on. History will be located here. It was created on this date and time. Gives you the IP address that you could use if you're going to use SSH, for example. And then if you're going to connect with SSH, here is the IP again, and then you simply hit connect. This also gives you information here that you might want to know on how to connect. If you're going to use PuTTY, again, you can use that if you like. That again is how simple it is to deploy Lightsail. And these are the instances that are available on the Lightsail dashboard. And you can just simply go over here and create another one and do the same exact thing. Select what you want to deploy and go through the same process. If you're going to use Windows, you have the ability to deploy Windows 2016 or 2012. And then here, SQL Server is available as well. That is the end of this demo. Let's go ahead and move on. Let's talk about CloudFormation in this demo. Now, CloudFormation is Amazon's version of infrastructure as a service. Basically, we want to use templates to create a repeatable and predictable process. When we select CloudFormation, we want to go and look at what we have first, and that is called a stack. Now, what is a stack? Basically, when we look at a stack, we want to consider this as a configuration with basically a bunch of templates and configuration files, and they work together to deploy resources in a predictable and configurable manner. Basically, when we select a stack, and I'm going to select the one I have there, this is a basically a Lambda deployment. And you can see here it's a sample Hello World app. It tells you when it was created, the stack ID as well, anything that is available in the policy. I go to events, it lists those events. Parameters are listed here. Basically, not much to it, very simple. And then the template that is used is actually here, very simple template. Basically, the template is calling the service. It is giving you first the version number, describes what it is, then the parameters. Now, this is an YAML, and it's very predictable, very declarative for that matter, I should say. Now, I could also change the template in Designer if I want, and then I go over here to change sets. I don't have any sets created in this case, but if I did, I'd go ahead and do that. And if I go here to the change set ID, right here, now the change set ID is basically this. This is an execution process that has occurred and deployed resources. The input that was used is called the identity name parameter. It's called test app. And then the tags that are used are listed here. and then any other information is here. And then the JSON changes are listed here. This is in JSON, of course. With that said, that is CloudFormation. If I go back to CloudFormation, I have stacks and then I have stack sets. Now, if I select stack sets, I can basically create a new template, or I could use a sample template. I would then select basically one of these, like enable AWS CloudTrail, basically multi-factor authentication, guard duty, for example. I go to next. This will go ahead and put together a description for me automatically. The master ID will be the stack set. Then I can go ahead and say guard duty. I'm just going to put something simple, go next. And then I can put in keys, basically guard duty. And then I'll just put security because it's a security tool. Permissions, again, I don't have any sample roles. Again, I could go ahead and put in whatever I want for that. And again, this is optional. I could basically have it tied to a default or not. It's up to me. Go next. And then I could deploy stacks and accounts or an organizational unit. Then I'd need to upload the account numbers. And then I need to then specify regions, so on and so on. And then any kind of deployment options. And again, I need to add an account ID. I don't have that ready, but after you do that, you go next, and then there's some more information to fill. But basically, you review it and then you deploy it. And that is really CloudFormation. And then exports, this is where we would go ahead and export a stack, basically. Now, Designer here is, as you see, it's really almost like an IDE environment. And that's really what this is meant for. That is CloudFormation. We want to use that to deploy a predictable and repeatable format for our cloud resources in AWS. In this whiteboard, let's go ahead and talk about how we would connect from on-prem to AWS. Now, when it comes to connecting, we're probably going to be using certain protocols. The first is going to be SSH, and the second would be RDP. That, of course, would be Windows. So SSH for Unix and RDP for Windows. Now, if we are going to set up a connection strategy, then we also probably should consider as well, as part of this, of course, some other protocols like HTTP, HTTPS, for example, and of course, if we want to use SNMP, etc., we also could consider that. But for the purposes of this whiteboard, I want to really focus on connecting to the virtual machines and understanding how we would want to set up our connection strategy and then also a deployment strategy for EC2. Over here, let's say this is our EC2 instances. This would be our load balancing. And we would have over here basically a VPN in this case. Let's say we're not using Direct Connect. We're going to go ahead and use a VPN. And therefore, over here, we need to have what? A gateway to gateway VPN setup. So we could use a managed service if we want. And whatever makes sense. Again, we could use a software-based, or we could also use a managed gateway. As long as the on-prem gateway is supported by the managed service, then you should be good to go. Let me get my pen now. And let's talk about the first thing we want to consider. If we have developers at Site 1 and they want to connect over the internet to AWS, then we're going to connect over VPN. However, we do not want to have our developers, for example, just go ahead and go directly to the EC2 instance, right? We don't want that. What we want them to do is to connect to what would be called a bastion host. And again, a bastion host is going to be basically, in the world of Unix, we might call it a jump server, for example. Now, what we want to do next, for example, is connect from the bastion host over to the EC2 instance, and that would allow us to SSH in. Now, we could also think of the bastion host as a SSH concentrator as well. Now, if we want to connect with RDP, for example, then we'd need to have a bastion host as well. But again, if you're going to use that approach, just make sure that everything is supported in the manner that you need for your version of Windows, for example. So that would be the first few things to think about. Now, what about if you're running programs on EC2 and they have to traverse the internet to go pull, let's say, information, or pull information, let's say, from Site 2? And to do that, we need to consider a few things. So maybe it's also the internet, whatever the program's going to pull. Let's say they want to go get a stock query, or they want to go pull and get currency rates, whatever that scenario is, or they just want to go ahead and dump some data in a bucket somewhere else, whatever that is. We want to also be very cautious of how we allow the programs to go and access the internet. What we want to do is set up basically what is called a NAT server, and there is a NAT service that we could use as well for this. And again, whatever we want to do, it's up to us. If we want to deploy a VM for this, we can, or we could use AWS's managed service. It's really up to us. And this way, what will happen is when all the programs are running, whether we have one of these or we have 3 of these all traversing the internet, we don't want to give out our IP addresses of each of these, right? What we want to do is give out a pseudo IP, basically, that will not give away our EC2 instances. From a connection standpoint, from a deployment standpoint for accessing our VMs, we need to consider a bastion host, a NAT server, also a VPN service as well as part of this. With that said, let's move on to the next module. Auto scaling. Let's talk about auto scaling with EC2. Now, auto scaling is, of course, going to be used to ensure that we can meet our target workload requirements. Auto scaling is going to increase or decrease the number of available instances per any policies that we set. Auto scaling is really needed to meet that workload demand. Auto scaling as well is going to be complementary to each other. In other words, auto scaling and load balancing work together. They don't work against each other, and they're actually different. And we'll talk about how that plays in before we close out. Auto scaling basically monitors our apps, and we could also, again, specify via policy on how to scale so that we have a good user experience, predictable performance. We want to also ensure that we minimize any downtime. This also can help as well. Now, with auto scaling, again, we could set what's called a threshold value via a policy. And for example, if I have 2 virtual machines in that group running, and both of those VMs are well under 20% utilized, let's say I could create a policy to basically say turn off one VM because I've reached that threshold to remove instances. And then when the workload goes up or I change the policy, could add more resources to the group. Auto scaling does support auto scaling groups. It also supports container service, spot fleets, and also replicas as well. one thing to be aware of with auto-scaling is that we could use auto-scaling with, of course, CloudWatch. Now, CloudWatch is a monitoring service that allows us to monitor the health of our resources and applications on AWS. Now, also note, CloudWatch really monitors the health of the resources that our applications run on, just to be more specific. So if we deploy an application on EC2 and that has an instance group of 4 VMs, that'll monitor those 4 VMs, and we basically affiliate those VMs with an application. That's really how that works. Okay, let's talk about auto-scaling and how it compares to load balancing. One of the things that can come up and can confuse people is that load balancing, auto-scaling, or the auto-scaler, for example, that we could use is actually the same or different, and how does that really play in? Load balancing is really meant to distribute the workload to application instances in all availability zones in a region, while auto-scaling ensures that your EC2 instances can scale up or down based on the workload. So you want to use the auto-scaler to scale up usage, for example, and then increase or decrease dynamically. Remember, we're going to do this with the policy effectively, and we're going to, of course, ensure that our policies are set to trigger on a threshold. We could use CloudWatch as part of our monitoring capabilities. We want to minimize downtime, and the best way to do that is to use load balancing with auto-scaling. Now, the load balancer, again, distributes traffic across all the instances available in that target group that we create. Basically, it's going to monitor the health and route the traffic to the appropriate instance that's available. And load balancing, though, will route, again, to the available instances. So if it doesn't see an instance available, it'll route it somewhere else based on, again, the policies we create. So auto-scaling will scale up, though, and add additional resources to meet any kind of workload demand. So basically, auto-scaling increases or decreases the number of instances, whereas load balancing basically redirects traffic effectively. But we need to have both services running in an effective application deployment. Let's now move on to the next module. EC2 cost optimization. Let's go ahead and discuss pricing and how to reduce costs with EC2. Now, this module is really an introductory module. Again, we can't cover every little detail, but I want to make sure we cover the main points that I think are important so that you can make the right decision on whether or not EC2 will be the right decision for you. Now, when it comes to deploying EC2, basically it has a pretty standard but different pricing model as compared to other providers. Now, every provider has on-demand instances, for example, and even reserved instances, but the one area that's really different is how AWS handles spot instances. And I'll talk about the difference between the 3 types of instances. Basically, the pricing model that we want to understand is that the most expensive type of instance is on-demand. So on-demand is basically going to be an instance that we say, hey, we want to go ahead and deploy this now, and we can go ahead and pay for what we use, and we don't have to place any commitment on hand or pay up front like we would have to with and reserved instances. Now, a reserved instance is typically going to be a one-time commitment for 1 or 3 years. And that commitment can, of course, last for 1 or 3 years. And the rate that we get for the compute power that we're basically committing to needing and using, we'll get a lower discount or a lower price. Now, that again sort of is important to realize, because if we do not have the need for 100 VMs, let's say for 3 years, then we don't want to, of course, commit to that. If we just need 20 instances now for a month, then we're going to use an on-demand instance. That's really the main point. Now, lastly, we have a spot instance. Now, a spot instance is going to be EC2 resources that are available at a lower cost, could be up to 90% compared to on-demand instances. Now, it's important to realize that these are short-term instances. They're typically instances that are available via what's called a spot auction. We could also request them, and if they're available for the price that we agree to, we'll get those instances. Now, the challenge with a spot instance is that, again, that instance is going to run for pretty much up to 24 hours. Now, there's also basically defined durations. These are called spot blocks that we can look at as well. When it comes to minimizing costs, one of the things we could do, for example, with reserved instances, is we could go ahead and pay for that commitment up front and get a reduced cost. Now, AWS has 3 payment options. It's all up front, no upfront, or partial upfront. Now, the greater discount is pretty much all up front. The second greatest will be partial, and then no upfront is still a discount compared to on-demand, but it's not as great as if we paid everything or part up front. Now, again, when we deploy reserved instances, for example, these instances, again, are going to be based on a commitment. They're going to be 1 or 3 year terms. There's also 2 different classes. There's standard and convertible. I won't go into the details for this course. We will talk about them in the more advanced courses. Now, there's some other things we can do to reduce our costs with EC2. So we know that pick the right instance with just enough resources, that's going to help. Now, AWS has some great tools called Trusted Advisor, Cost Explorer, that we could use, for example, to determine, is that VM being utilized or is it not? These are things we could look at to help reduce our cloud spending. Perform an audit. And then also, too, there's lots of great third-party tools we could also enable with the cloud marketplace or extend as well if we so choose as well. Let's now go ahead and proceed over to a demo on the AWS Marketplace and find out more about options available for deploying applications on AWS. The AWS Marketplace is where we want to go to find, basically via a catalog approach, software solutions that might meet our requirements. Basically, the first thing we want to do is go ahead and find a solution. What we want to do is go here to Manage Subscriptions. Now, let's say, for example, I want to find solutions that are going to be, in this case, blockchain-based. So if I type in blockchain, you will see that it'll pull up different blockchain-based solutions. And again, there is several available over here. So, for example, the Collida Enterprise Blockchain Solution is available. Then if we go furthermore, you can see that there's Hyperledger Sawtooth, and then on and on and on, R3 Corda as well. Well, let's say we don't want to have a blockchain solution. We want to look for DevOps-based services. And to do that, what we want to do is actually clear that out first, and then look for DevOps solutions. And with that said, we could look at Agile development, application stacks, for example. Over here, we have WordPress, LampStacks, Palo Alto Networks. Again, these are different products. Some of these, I'll be honest, are not really lining up per se, but let's make it simple. Let's type in, let's say, Jenkins. Now, here is where we could pull up different versions of Jenkins. As you see, there's a numerous amount of Jenkins-based solutions. So again, if you want to deploy a Jenkins solution, probably you'll find a solution worth your time. Now, the way this works is going to vary on a few different variables. Some of these solutions may be free. Some you'll pay for just the resources, and some you'll have to pay for the resources and or a subscription to the service. So it really depends on what you're trying to do. Now, let's go over here to the CloudBees Jenkins distribution, which is generally a popular one. Surprises, no reviews. It costs about 12, less than 0.012, less than a cent per hour. So it's not really something that'll cost a whole lot. And this will basically allow you to deploy Jenkins without having to deploy a full LAMP stack yourself. And this will work by deploying the CloudFormation stack. So if I go down here, I just select where I want to deploy it, what EC2 region I want to deploy it in, and what kind of a virtual machine I want to use. It is free tier eligible. And this tells you about the distribution. And it also tells you how the templates work. And it is CloudFormation. And you simply go here to continue to subscribe. And when you accept the terms, it'll deploy this via CloudFormation. Now, for the purpose of the demo, I won't subscribe because it does take a little work to unsubscribe. But basically, it really is that simple. Once you accept the terms, you then would basically deploy this, and it would be up and running. And then you would just go back to CloudFormation. Once it's kicked off, you would see that there would be another stack here, essentially. That is really the cloud marketplace. Let's go ahead and move on. Let's talk about the pricing calculator. Now, the link for the calculator is simply calculator.aws. Now, there's several calculators out there in AWS. This is really the newest one to go to. They're constantly updating and migrating to pretty much this newer approach that we're going to review. So this is the one I'm going to use. Now, the pricing calculator we want to use to, of course, understand what would be an estimated cost, for example, to deploy 100 virtual machines in EC2, or we want to use, a terabyte of data in S3. So we want to be able to understand what the cost may be, and this will help us from a budgetary perspective to understand how the cost will come together. To use the calculator, we go to the calculator webpage, and then we go here to create estimate. And you can see here they have two steps. The first is to select the service, and then you configure the service. And as part of this, we're going to just go ahead and use, in this case, EC2. Now, EC2 is going to be our infrastructure as a service virtual machines. We're going to go configure. On the page here, we're going to just scroll up. We want to be cognizant of some options first. We want to select, first of all, where the EC2 instances will be. I'm going to use the default of Ohio in this case, and just leave it at that, just for the demo. Now, there's a quick estimate and then an advanced estimate. And the difference is it just gives you more options and a little bit more granularity into how you configure your estimate. The first thing is, after we select the estimate type, we would then go and identify the operating system that we want to use on the virtual machines. I'm going to leave it at Linux, and then enter the minimum specs. I'm going to leave it at the default in this case. Now, we want to specify how many of these instances we want. I'm going to go 100 EC2 instances. Then the pricing. Remember in the earlier modules around the cost optimization, for example, we talked about the pricing capabilities. For example, an on-demand or spot instance. and also reservation, which is a reserved instance. We also have different payment options we could select. In this case here, I'm going to go and just leave it at the default here, reserved instances, no upfront. And then I go over here to show the calculation of how they come up with this. Let's say if I want to pay upfront, it's going to give you, for example, that estimated amount based on that configuration. If I change it to no upfront, it'll be basically based on a monthly level. Now, generally, if we're using EC2 instances, we're going to need to have some instance storage as well. By default, it's going to use GP SSDs. However, we could choose that to provisioned, magnetic, or basically throughput optimized or high optimization is another way that it's referenced. Again, I'm just going to leave it at the default. You can see here that based on the default settings, I'm looking at a monthly cost of $7,000 per month. I'm going to add that to the estimate. Now, what I want to do is add another service. I'm going to go down here over to, let's look for, in this case, Amazon S3. And you can see here I have S3 Glacier. And if I go down, I have Simple Storage Service. I'm going to go configure that one. Going to scroll back up. And again, remember, I need to select the region first of all. Remember, services always are priced based on the region. We want to select the different storage classes we're going to use. We want to estimate, for example, the amount. In this case, I'm going to put in this case here, I'll just put in 10,000 gig per month just as a base estimate. Now, one thing that we want to remember is that we're going to also pay based on the number of requests. And what does that mean? In other words, every time you get something out of cloud storage, you're going to get basically charged for that. So with S3, that is, of course, what we need to plan on. Now, in this case, I'm going to put, let's say, what is that? 20,000, let's just say. And then I'm going to let's just say it's even. Now, in reality, there's a lot of planning you're going to have to do to really get this close to correct. And then data return, I'll just leave that as is. So you can see right there, just based on that, it's $230. And then again, a lot more we can configure. The tier also will affect the pricing as well. So if you scroll down here, just based on the first estimate that I created, that's the cost. And it says that it can't be calculated. Again, that's because I just skipped over this. And to get around that, probably the best thing to do, just for speed, is just to go and deselect these actually. And make that a little bit easier. So that's S3 standard. I just want a price. And then data transfer. Okay. One thing I did forget to mention is there is free transfer and not free transfer. So when we go over here, we need to pay attention to several things. We need to pay attention to what is free. In other words, you get a free allowance and there's a paid allowance. So once you get above free, you then have to start paying basically. In this case here, I'm going to just say it's a small application and just go 1,000, just to make this quick and easy. And then I'm going to, let's say, now also too, I want to just point this out. To go to Northern Virginia, the cost is lower than to go to other regions. And if you go to CloudFront, it is free. However, to go to the internet, it's going to vary based on several factors. So just be aware of that. And then you could add this to the estimate. Now, you could see based on that estimate, the storage will cost quite a bit, right? So again, the more activity you have, the bigger the cost. So a couple things I just want to clarify. It's not cheap. And why is it not cheap? You could store a small amount of data in AWS, but if you have a lot of folks accessing that data, that's where the cost will get a lot of people. So just be aware of that. This is a rookie mistake that a lot of people make. So you can see here, this is the estimate. And then what we go over here and do is save and share. I copy the link, and then what I could do is go back to that later if you want. And then again, I could always reference that. With that said, that's just a rough estimate on how to use a calculator. And as you can see, there's a lot of other services, and you need to do each service individually. Let's go ahead and move on to the next module.